Hello and welcome to Arm DevSummit 22. My name is Kiel Friedt, and this is Reaching Escape Velocity with 5G Infrastructure on Arm. Hi, so I am a Principal Solutions Engineer here at Arm. I primarily focus on 5G networks, mostly porting efforts, and some of the testing and MVP POCs. And I also dabble a little bit in the networking with Arm technology. So for today, the agenda is going to be kind of the 5G progress within ARM, some of the merits and deficits of ARM, and then we're going to do some comparisons between ARM and x86. I'll discuss a little bit more about the past, the present, and the future of ARM infrastructure on 5G. This is going to be mostly a talking kind of experience, stories kind of aspect, less of the slides, so hopefully everybody enjoys this a little bit better. So this is going to talk a little bit more about 5G dominance, the progress of what's going on. So I showed the diagram on the left from a CNCF presentation back in 21, and then I'm going to compare it to 2022. So the engine that is 5G and its infrastructure that's going on has been in this design phase for a long time. You know, I would say it's probably late 2010s. Is when these companies were working on. So we're talking about Ericsson, Nokia, major telecom networks have kind of designed, thought about this, developed the hardware, maybe proprietary, not proprietary, COTS servers. And then from that, developed, did testing, and then went to the deployment phase of these. So really the engine that is of 5G and its dominance over the rest of the world and, moving past 3G, 2G, and 4G, LTE, that kind of aspects, that's kind of going to continue moving forward. During 2020, the pandemic happened. That did slow it slightly down. I wouldn't say it necessarily stalled it, but we were at a slower RPMs, I guess, if that's a good analogy. So for the diagram on the left, that's from 2021. So you see a lot of countries that are going from the investment phase and kind of going to deployments. And then we go to countries on the right, which unfortunately, I'm sorry, the coloration's a little disappointing. You see a lot of countries, especially within the continent of Africa, that are deploying, planning, and actually deployed systems for launches. People are actually using 5G in those countries now. So you can kind of see the progress is relatively slow, I would say, compared to what I would think it would be without the pandemic. But in general, we're still pursuing 5G. It's very much still a thing that's going on. And I would still say, I think the deployment's just going to continue getting faster. I think that also the other aspects you should think about this is even though some of these countries within these continents are, still in the launch phase or they have deployed it, really it's becoming more and more infrastructure that's based in there. So now instead of having it in one target area like a major city, we're now moving to more suburbia country, deploying different aspects of what 5G really is. And I'll talk about those in the next slides. Here I'm going to talk a little bit more about 5G network evolution. So if we're talking on the diagram on the left, the traditional RAN, we're talking, more of a traditional setup similar to 3G, 4G networks. You have a large server, you have large racks, probably many racks, and each one of those are typically, a not off-the-shelf server. Those are proprietary. Those pieces of hardware, when need to be fixed or replaced or upgraded, I just hope you have a very large checkbook for them. The nice thing about 5G and what we're trying to achieve is that you can break this giant monolith up into different components. And then maybe each one of those components itself can run a different system that maybe is a little bit more optimized for it. Or in this case too, you could also push some of these aspects to the cloud. So you can kind of scale up and down dynamically. You can put them in different regions that necessarily the hardware is not necessarily available to. And this helps kind of spread the load and be able to produce a much better experience overall. So less of the throttling, less of the issues with, you're getting it kind of, you're tapping out on your throughput, and more of, hey, I need to, streamline this process a little bit more. I can make these changes very quickly. I can upgrade technology and hardware and software very quickly, thus producing a better experience for the end customer. this is a kind of a continuation of the previous slide about the different aspects of those three systems there. So we're going to talk a little bit more about how it's progressed. Unfortunately, the video is over this time, but you'll be able to still see the deck slide. As we've progressed over time, we're doing less and less conventional systems. You're putting them into a rack, you're doing that, you're keeping them there and, collecting dust off of them. You're moving more to cloud-based, and that's very evident in the diagram that's shown here. So the idea is that you can go ahead and reduce the amount of costs on these these expensive pieces of hardware, less of, having to have them in a location, and less of dealing with the replacement aspect of it, where you can quickly upgrade, do software changes, hardware upgrades all through the cloud and its providers. Now, I want to talk a little bit about the technologies that are available in some of these areas of the 5G stack. These are some of the examples of this. This is not necessarily a complete picture. A lot of times these can be mismatched or changed up. It kind of really depends on the user. When I say user, more of like the telco or the company that's producing it. Maybe they're more heavily on some aspect of the stack that they need to optimize. And a good example is some of these ones here. So one of the tests that we did here for MWC was with Ampere, Capgemini, and I'll talk a little bit further on with our use cases. But as you can see, different components can run different things, different ARM aspects of each one of those, using different people's, different companies' versions of the software, and help optimize them on different aspects, different versions that is needed by the user of this. And now let's move on to the ARM merits deficits aspect. So I'm sure that this has been drilled into everybody, especially with ARM as the merits. We're talking about low power. We're majority of the time we're in cell phones, now we're in infrastructure, now we're in servers. Still, that power base comes along with us here. So lower power, lower costs. Typically, these solutions are optimized, especially with the telcos. You're wanting to optimize it for that particular area. So in the previous slide where we talked about different components being in different parts of the stack, that really helps with that. And then you're also avoiding vendor lock-in. That was kind of one of the things I mentioned originally with a lot of these proprietary pieces of software software and hardware, is that when things do break or you need to replace or you need to upgrade, hopefully you have a very large paycheck for these, because these things are not cheap. We're talking, tens, if not hundreds of thousands of dollars in some cases for pieces of equipment. Now, onto the deficits. So we have limited ecosystem. We're relatively young compared to Intel. Intel has been, or I shouldn't say Intel, actually x86 in general, has been dominant in this play. We're relatively young in this, but the thing that we're trying to do is really push into the market to show the advantage of ARM and its low power, high efficiency, and we'll talk a little bit more about that in the future. And then also temporary lack of COTS server options. A lot of these are ramping up at this time. It's it's like anything else in this world. There's a lot of ramping up to get everything going, especially with the pandemic. That slowed a lot of this down here too. So it's eventually going to be much more a much larger ecosystem eventually, but it does take time for people to design, develop, and then push these products out into the mainstream. Now, talking about one of the merits of this that we mentioned before about power efficiency and performance is, there's performance efficiency on 5G workloads. So we're talking about an x86 machine versus an ARM-based machine, very similar in stats. We're talking 2.5 gigahertz versus 2. But the thing that we got here is lower power, less utilization on this of the power of the total system itself, because we're able to stack much more in each individual server. And I'll talk about that in the next slide about the difference compared to x86 and ARM, and how much we're able to basically put into a single machine and be able to produce a lot more work for power. Now, this slide talks a little bit more about the different services that we have within ARM and the number of cores. This kind of gives you a better idea of what's out there and why it shows that it's a very large potential here. So a good example is Graviton 2. Obviously, Graviton 3 is currently already out as of this call. As of this talk, and we're talking about multiple cores, and in most cases, many more cores than typically is found in an x86 machine at a lower power. So a good example of this, Graviton 2, 64 cores, single CPU, and in some cases we can do double or double CPUs on a single machine. Ampere, the Ultra Max, 64 to 128 cores. So we're talking about a lot of potential to be able to efficiently run all these services on a single machine, and less of having 4 or 5 servers on a single rack can be condensed into maybe 1 or 2 to do the same workload, if not more efficiently, power and performance wise. I also wanted to highlight one of our private ongoing labs here within ARM. So we have multiple different services that are set up that are doing different categories of this. So we're talking containerized, enterprise, low footprint, carrier grade, and as these are household names that are on here. These are not just random small companies. These are big things. So Ampere mentioned before, 6428 cores, very large, gigabyte, well-known systems there. That's kind of our first COTS server that's out there with many more to come. And then the OS is associated with it, Ubuntu, household name, Red Hat with OpenShift. And then as we progress, all these different examples are now ongoing and ready to go into labs and be able to demonstrate throughput, performance, and do some comparisons, especially to kind of bring on more telcos and a lot more confidence into the systems that ARM is a real player in this, and that will continue to drive into this market. Now we're part of the slideshow that's going to be less heavily on slides and more on talking of experiences. So I'm going to start off talking about the past, the present, and the future of ARM infrastructure on 5G. Here I'll talk a little bit more about the past projects that we worked on. ORAN SC, one of the things that I ported personally from x86 to ARM, and then we'll talk about MWC, Mobile World Congress, that was done in 22. So for ORAN SC, I primarily worked on the RIC, which is basically porting that from x86 to ARM. This is the really good example of why 5G is an interesting topic, is with XApps. With the RIC, we were able to port different applications from simple hello world to maybe optimizations within 5G networks. And the idea was for us to work with ORAN SE and its community and to port this piece of heavily used portion of the 5G stack, and then try to do some more performance analysis. And I'll talk a little bit more about how that worked out. I'll also talk about the negatives of this, which is the upstreaming failure that occurred. So before I go into the experiences, I want to talk a little bit more about why ORAN SE was the first one that we worked on here. So I worked on the porting process of that RIC. And the reason being is because previous to 5G and its kind of standards associated with this, we're talking more on 4G, X2 interfaces, and each one of those have their own lock-in. Typically, vendors had their own version of an X2, and then mobile networks typically had one RAN vendor for one location. There was no mismatching. There was no using maybe a better system when needed. It was kind of like you were stuck by the playbook of the person that you purchased for originally. Now, the reason why ORAN SE was kind of the first step in this is because look at the sheer amount of operating members within ORAN Alliance. AT&T, Orange, T-Mobile, Dish. I mean, you talk all these major vendors, these telcos, these operators. That's a pretty big deal. That's not just small, potatoes. We're talking big deal. So that was kind of like the first step in this evolution of like, how can we get our feet, in there and kind of push our way in there to show the, why ARM is a big deal. So I worked on the porting of that RIC, moved it over from x86 to ARM. The porting process was pretty simple overall. There was some modifications that were heavily x86 swayed, and some of those examples are some of the assembly language changes on there. So there's quite a variety of difficulty on some different components, but there was a very large number of components. I think at the time there were like in the 20s. So each one of those had to be ported, moved over. But the problem that we or at least I really faced here, was that when we went to take the product and upstream it, it became more of a difficulty get a hold of the group, the people that were Linux Foundation, working with them to try to get this upstreamed and moving. And what would end up happening is the product, the RIC, would then continue evolving along its way, and then we'd have to make these implementable changes all the time to keep it going on there. And then getting acceptance into upstreaming was a very difficult thing. I mean, in most cases, they were very much an Intel shop, x86 shop, and when offered an alternative that may be better, that is better in some cases for this here, it was just kind of straight up, we don't have the time for this, so you're going to have to manage it yourself, maintain it yourself. And then we also kind of noticed also the community in general, when working with these people, there was a lot of them that just kind of disappeared. They were there to kind of view and look at things, but not necessarily to provide any type of help. So that was kind of like the first example of how we progressed and kind of learning and growing from this to figure out what the next steps were. During this time, we were also working on MWC, doing a full network in a box with a Mac. So we were working with a vendor, Capgemini, also I believe at the time was Altran. So we were working with the pieces of software on a single machine, on an Ultra machine, 80 cores on this. And the idea was for us to bring it to MWC to show an actual EU, a phone connecting to the system using all ARM infrastructure on this. And I provided a link down below to kind of show you a little bit more about that, where you can watch the entire demo of it. The idea is that, the phone was connected to the network. I could then browse to something that was internal to the system, which happened to be a video game, and being able to show that it's playing in working fashion. So that was kind of the next big leap from ORAN SC, was getting not a component, but the entire system up and running on an ARM server and showing that this is actually capable of doing something, and then focusing later on how do we work on, doing comparisons, performance analysis, those kind of aspects further. But this is kind of like stepping stones. And now we're from the past to the present. So the next real big step was to find some alternative to the ORAN SC group, and to find something that is much more evolved, has a lot more potential, and maybe is actually even in the market. And a good example of that was ONF. So while working with ONF, we kind of figured out how do we want to set this up, what do we want to do, and that's where we moved on to Aether and SD Core, and I'll talk about those next. So Aether is kind of like the orchestration aspect of this. With ONF, you can take different components and manage many different items on there. So a good example of this is, if we have multiple levels of ONF products on there, I can control maybe the routing, the switching systems on there to help evolve or help increase throughput on a certain, a certain aspect or a certain product. A good example, maybe quality service, voice, or whatever it is. So I need to make those changes almost instantaneously, and in doing so, I can make a call to another piece of hardware running ONF, software, and then say, hey, this switching system, I want you to increase the throughput of the quality of service to a better service for voice, and then it would just do it instantaneously. So this is kind of like the next big step of the evolution of like porting it, figuring out what the next steps are. So I worked on the porting effort of this here. So this is the initial Aether system. So this is the ROC and just the base system itself. And this is a screenshot showing that it's running on ARM. So this is a complete x86 product right now, in the process of being ported. We're also porting the SD Core, which is the next step in this entire Aether in a box, which is the SD Core, SD RAN, and then Aether itself. So we're making good progress. We're going through that, and hopefully that should show up with the next future, the past, as being completely ported, available to users, and available for them to use and show performance on that. So present is now future. So what are we working on next? A good example of this is OpenShift. So with Red Hat, working with them to try to optimize the software and make sure that all the services that are available on x86 are also available on ARM, and then going through some of the comparisons of that. And that's one of the things that I'm working on now, is working on getting OpenShift and all its components running on an Ampere service, running benchmark runner on there, So kind of go through and do some performance analysis on that. And the next step is to kind of continue the evolving process to get some type of network running on an OpenShift system. We'll continue working with ONF. As mentioned in the previous slide, we're going to continue getting the SD core, SD RAN, and the entire system up and running, connected to a radio. That way we can provide a kind of apples to apples comparison to something that actually is out there in the real world, running an x86 product, and now ARM, doing comparisons, and then going and showing telco operators these different components that ARM is a real player in this group. Now, ARM has the potential of being in every component of the 5G stack, and that is definitely somewhat of the case. There are cases where maybe ARM could be better based in a certain, CU, DU, whatever it is, and that's still a potential of being a great money savings aspect, and being able to control a little bit less of the frustration that you have to do with the vendor lock-in, and more of seeing it being tuned and optimized for each one of these users. That's kind of the hard thing, especially with telcos, is it's not just a one solution fits all problem. A lot of times, we're talking about dense locations, maybe in the middle of the city, and then you move to suburbia, and there's a tenth of the traffic that may be going through there, or maybe you have some super user that's dragging a ton, or maybe you have a factory that's close by in 5G that's using all these different systems to control robots or whatever it might be. So really, there is no one solution fits all, but the idea is that you'll see the optimizations over time in power, and being able to produce a lot more throughput, especially on a single system that has many cores. And then mention FNet, Druid. Those are all kind of future projects that we're working on right now, and hopefully I'll be able to show those in the future here very shortly. So again, my name is Kiel Friedt. I hope you enjoyed it, learning a little bit more about the potential of ARM on, infrastructure on 5G. I know it's a lot of times jargon, a lot of things that we're saying that maybe are more of 5G individuals that are kind of in the network and know how to understand what I'm trying to say here. Hopefully I tried to make it a little bit more of understandable, and kind of showing the examples of where ARM is a really good potential fit in this, and where the performance is. Definitely the goal is those future projects of getting ONF running completely on systems and OpenShift. Those are kind of the two big key players, and then being able to provide good comparisons, these apple-to-apple comparisons, less of these, I have one on x86, I have one on ARM, but they're completely different vendors or, software. So not a really good comparison. The idea is that we're going to get one-to-one. That way we can really show the difference and why ARM is really big in this. Thank you again for joining the Arm DevSummit 22. My name is Kiel Friedt, and I hope you enjoy the rest of the show. Thanks. Bye.